And thank you the entire team of the complex engineering systems to make it very, very simple and for the benefits of the world, bringing the complex engineering system in a simpler form. So as a tiny piece of the entire system and team, let me thanks to the entire team of complex engineering system, all the listeners, Professor Hamidi, Professor Vio, for providing this opportunity. Uh, I'll take around 10 minutes of time to complete my presentation. Will not prefer to go insights as I know that the audience is of the broader range from the different streams of the engineering disciplines and science and technology. Then my last attention is basically to bringing the try to I mean it's just a proposal from my side that to introduce the some of the new possible streams what probably I believe that will be able to enhance the readership of the journals introduced by our complex engineering systems and thereby increasing the our reach to the audience across the world. So it's one of my very popular closed loop systems to define the role of the sensors as far as the smart grid environment are concerned, or in the world of the sensor networks, is this. So it is a typical closed loop system. We could appreciate normally we studied this kind of thing under the head of control systems. What the objective of this particular slide is that the role of the sensors and as well the sensor networks, what we call today, they are not indifferent in the today's world. Or the some of the people we called it measurement systems or the measurement and instrumentation and all. They all are the synonyms of one another. What a critical role it can be play as far as any particular system is concerned. So as we can notice that the sensor is nothing but it is one of the very tiny piece, but it is the forefront as far as the measurement is concerned. Whenever you are going to pursue some measurement, so it is a front end device which is going to measure, which is going to sense something, some physical or the chemical phenomena, and converge it into the equivalent electrical signal. Okay? Why we prefer the equivalent electrical signal? Because as a human, as an engineer, for us, it is very easy to store the electrical signal. It is easy to process. It's easy to memorize. Okay, is it easy to display? So because of so many advantages, we convert any physical phenomena, any physical variable or the chemical variable into the electrical form, and thereby do our necessary analysis, okay, with the help of our embedded algorithm, and then we respond back to the field with the help of an actuation system. Now, this actuation system, as we know, it can be hydraulic, it can be pneumatic, it can be in electronic systems. So if you see, the role of these sensors are equally important in the today's scenario. If you look at the present age sensors, so these are nothing but it is a smart sensors. Why we call it a smart sensor? Because they not only sense the data and send all the raw data to the control center or the human machine interface, rather they basically process that particular data, able to have an ability to have some decision making at the on the spot itself, and also embedded by the network ports. Okay, so that without any further interface or seamlessly, the data can be transferred to the display system, to the memory, or to the controller for the further processing itself. So typically, these are called the level 4 sensors or network sensors embedded with the network ports. And why they able to provide the seamless communication? Reason is that they always follow the same standard what your device follows. So easiest example I used to give is like that whenever you insert your pen drive into you fetch into the your laptop or your desktop, you see that it never asks you for any permissions. Okay, they able to interact with one another. Why? Because the port of your laptop and the port of your pen drive have both have the follow the same communication specifications. So when they both are at the same level, so communication specification, it means in a easier language we can say they are able to interact through the same language, right? So if I will say in India, say for example Hindi, and if I will, if someone is know only English, then probably we are not able to interact. So this is something kind of, this is what the job of your communication standards is. Typically these standards we follow. Now the same criteria is also live with your what you call uh, this smart grid phenomena. So you have to, as far as that this system architectures are concerned, it should have always the low latency, because normally it is the battery back, and the amount of energy you are going to hold on into this particular scenario is basically to prolong the battery life. Okay, so therefore the latency should be low, longer battery life, should be reliable, network should be reliable, low bandwidth requirement. On the other hand, if you look at the sensor, it should have a highly sensitive, or the resolution should be high. Okay, one of the specifications may not be both. At the same time, low power consumption requirement, high Q factors. Okay, and there are some other static parameters also we need to check. So we take all these checks or variables, okay, static variables, dynamic variables, to overall check the effectiveness of your design or effectiveness of your product, particularly when you are going to embed it on the field. Okay, so if you see the current trend, the Internet of Things enabled smart sensor. That means all the Internet of Things technology should be embedded as a part of your signal conditioning device. And whenever we say smart sensor, that means both your microelectronics or nanoelectronics, what you call, to design and develop a signal conditioning circuit, and the micro machining technology. Okay, so what we talk about to design the sensing part. So the sensing and the signal conditioning both should come over the same platform, over the same substrate, should be able to fabricate it. Okay, using the embedded with the IoT technology. So when I say IoT, because here we have a broader audience, so please be noted that we basically use the different terminologies, right? If you ask me, and who is a guy from the electrical sciences, we, particularly who works in the smart grid domain, we called it cyber physical system. So Internet of Things is nothing for us whenever you are able to apply the Internet of Things on hardware. So it is, for us, it is a cyber physical system. On the same hand, I think that even Professor Karimi would appreciate, from the mechanical science domain or from the industrial domain, they called it industrial IoT. So the idea is that we use a buzzword and try to reciprocate in a different way through the different terminologies. Okay? So when you talk about the substations, why we suddenly say substation? Because please be noted that as far as the particular, I'm talking about transmission substation, where you are bringing the power, to basically empower our entire city, okay, and urban life. Fine. So in that particular scenario, these transmission substations are nothing but it acts as a heart of your body. If the transmission substations fail, please be noted that the entire load distribution of the entire region, typically we called it regional load distribution center, will be definitely hampered, and probably it may lead to the collapse of the grid in a regional level. So these SF6s are basically used to compact the design of the transmission substations. And but the limitation is that because it is a processed gas, and you cannot guarantee that the leakage will be zero. So almost 25% of the accident across the world happens. Accident means basically the failure of this substation happens because of the mismeasurement of the gas leakage. Actually, the sensor is able to detect the gas leakage, but it's very late. Okay, so that's why these contributions we have been made to develop a direct density measurement. What phenomena they use, they assume that even the current profile is there, temperature is uniform, which is not possible, because wherever the current is passing through the conductor, it always follows Gaussian distribution, not the uniform distribution. Okay, and therefore they assume that the pressure is constant, temperature is constant, and the pressure is variable, and able to measure the density. So the equation takes a lot of time. On contrary to that, we propose that you take care of the humidity concentration during the closed environment. Okay, measure the pressure directly and convert it into the equivalent density form. Okay, because if the gas is going to leak, so remember that the density is going to fall. Right? So how quickly you are able to measure? So we have introduced a couple of sensors which is able to measure the leakage even at the ppm level. Okay. So the response is almost 6 to 10 times fast as compared to the state of the art sensors available like traffic. It's basically Swedish sensor. Okay, has almost a 60% market cap in the world. So the performance of these sensors are quite exceptionally encouraging. Also, please be noted that in the future scenario, SF6 is not going to completely use. Right now, in the present circuit breakers, we use 100% SF6 gas. But because it is SF6 is not a toxic gas, okay, so it's a safe for human being at normal temperature and pressure. But on contrary to that, it will be if it is able to bifurcate at the high pressure environment or the high temperature environment, then the sum of the components of the chemical compositions of the SF6 is so toxic that it is able to penetrate the greenhouse gas almost 20,000 times more than that the impact of the same amount of the carbon dioxide. Okay? So it's that dangerous for the environment, okay, not for the human life directly, but indirectly. So that is why the recent trends are going on to increase to consider a different kind of insulation gas where the 80% nitrogen will be used and the 20% SF6 will be used to reduce the penetration of the SF6. Okay. So these are the kind of scenario. So I will not give you indulge into that part. Please interrupt me whenever you have a question in these aspects. Okay. So remember that as far as HVAC is concerned, that means high voltage AC environment. In high voltage AC environment, because the current profile is a sinusoidal in nature, so at 0 degree, 180 degree, and 360 degree, at least you got a point where you can detach yourself, fine. But not in DC environment, high voltage DC environment. So that's why the arc extension capability, okay, the need in case of the SF6 HVDC GIS is even much more, you can say, as a concern. Fine. So the degradation of SF6 gas and the quality of SF6 gas both doesn't matter, which we have introduced a couple of sensors. Like as you have seen in this proposed scenario, this entire integrated module, the sensor array is formed over the single substrate. So the phenomenon is basically the ultrasonic sensors we use, and for our experimental purpose, we use around 40 kilohertz range. Whereas the ultrasonic sensor, depending on your design requirement, application requirement, you can introduce right from around 30 kilohertz to 100 kilohertz, okay, depending on the range requirement. Fine. So this is the basically last such principle we use, where you can see in the bottom that basically the speed of this acoustic wave is actually a component of the temperature component of the relative humidity in a real time. So basically, what will happen in a closed environment, and when the density of the gas is reducing, now if you are going to penetrate an ultrasonic wave through it, and if the density is reducing, so what happened? The time of flight is going to also reduce. Okay, so time of flight is the amount of time required to hit the basically ultrasonic wave to the receiver end, okay, to the transmission end, and the come back. So this is the total amount of the time is taken to get back your response. Okay, just like in a Doppler effect, is basically called the time of flight. Fine. So obviously, if the density is reducing, the time of flight is less. If the density is more, the time of flight is more. Okay, so these are the couple of setups in our lab, including the auto data acquisition system. Okay, so it's just for your information, the response, the recovery time. Okay. So I'm skipping all these things. Please be interrupt if you have a more interest in these particular parts. Okay, so it's a 3D printed ABS PLA module, which is used to set with HCSR04 Centurion design. Please be noted that this design of this piezoelectric crystal has been actually provided by my team to this particular company. Okay. Centurion, it's basically the manufacturing is in China, so US-based companies. So, so this contribution has been patented under the consideration. Relative humidity sensors, couple of sensors we have been developed. One, the inorganic sensors and the organic sensor both. One combination we use the FTO and gamma Al2O3 as a sensing material. Okay, so the result is for ppm level detection of the humidity is quite interesting. The sensitivity is almost 0.2 picofarad per ppm. It's very, very sensitive, highly accurate also, along with the low hysteresis loss and lack of time. I'm avoiding the deep discussion of these particular aspect. One more sensor we have developed. Now this is able to detect the capacitive humidity sensor for the detection of the humidity at the percentage RH scale. So both the domain have been provided. We basically use the polyimide capacitive sensor with the polyimide as a substrate. So because both are organic in nature, so the bonding between the sensors is quite good. Okay. So we got very good performance in terms of the relative humidity also. This sensor particularly is designed to detect the very low level of humidity. That means almost close to range of from 0.2 relative humidity scale 0.2% to 20%. because our purpose is that objective is that there should not be no humidity. So if there is even a pinch of humidity is available even at ppm scale, you will be able to detect. Okay, smart plug. We introduce one more product. Has been again the patented. The smart plug is basically used to basically control any high current device of roughly around 30 ampere current and above device to remotely control that particular device. Please be noted, it is that not for only switch on and off. You are literally able to control your say home appliances devices, for example, your geysers, your washing machine, your dishwashers remotely from anywhere in the world, even your outstation. Right? So these are the couple of sensors in tested in our high electrical machine and laboratories. So I would be glad that if some point of time you will be able to visit India, we will be happy to show you all these products. Now the last slide is foremost of my most important, and I would like to draw the attention of the entire panel members over here. These are the couple of points that please we can have a brainstorm over it to introduce as a part of a complex engineering system. We are a new system, we are a new platform also, but I personally feel that there are certain domains which is basically now is a highly interdisciplinary. If you consider the civil engineering, if you consider the electrical sciences, if you consider the chemical sciences, if you consider the mechanical sciences domain, it's a highly interdisciplinary in nature. Right? For example, one terminology could be smart monitoring. Smart monitoring, or we can say it is sensing technology. So all the domain of the smart sensors, intelligent sensors, wearable sensors, I propose to introduce this one domain under the head of our complex engineering calendar. Okay, sensing technology is creates a buzz. In a simpler terms, we can keep it smart monitoring also. The couple of control system experts I'm glad to hear from them. It's on their code. But I also propose that to introduce a special window for the control engineering, particularly for the robotics and automation, intelligent control, adaptive control. Okay, we can fix up one domain for the industrial Internet of Things and cyber physical system. Okay, or we can fix up in a broader sense for the automation, the concern related to all the power generation and substation automation tools, industrial automation, biomedical instrumentation, system reliability, because system reliability, if you say it's common for the mechanical engineering and for the instrumentation engineering domain. And what the last one is the microgrids, because renewable energy is, we know that the role of renewable energy is enhancing exponentially day by day, considering the requirement to reduction the carbon footprint, impact over the temperature rise across the world, role of the electric vehicles, e-vehicles, hydrogen fuel cell based transportation systems, hydrogen fuel cell based hybrid energy systems. So this is my proposal to all the eminent members to with the permission to the Professor Karimi. I'm sorry that I don't take permission for this, but I thought that I mean this is one of my concern, that how do we increase the readership, how to increase our reach or the dimension by offering some new windows to participate or to publish the research articles through our complex engineering systems. So with this, I am up here. And so if you have any question, I'm glad to answer, or please feel free to contact me through my email ID is there. I will be happy to collaborate with you all at any form, whatever is available. Thank you.